let's explore equivalence through area. Imagine that this large tangram square represents one whole unit. Our job is to determine what fraction of the whole each piece represents. We can see this diagonal line right here splits this into two pieces, which means these two top pieces together are going to represent 1/2, and all of the bottom will represent 1/2. Since together these two large triangles represent 1/2, that means individually they'll be 1/4 each. Let's look at some of the others. If I take this one and I'm going to go ahead and turn it, I can see that it's half of each of these. So half of 1/4 is going to represent 1/8. What about our smaller triangles? I can look at this and see that it's half of this purple one, half of 1/8. Since it's half of 1/8, this is going to represent 1/16. And that'll be true for the other one that's an equal size. Next, let's look at this square. If I take one of these triangles, I can see that it is half of the square. So that means that this is also going to be in our 1/8 group. Similarly, it's going to take two of these triangles to make this parallelogram, so this will be in our 1/8 group as well. So we have two that represent 1/4, three that represent 1/8, and two that represent 1/16. Here's something students often wonder. How can two pieces be equal if they don't look the same? In my 1/8 group, I have three different shapes that look very different. And that's a fantastic question. For fractions based on area, shape doesn't matter. Area is what matters. For example, my small square and my parallelogram may look very different, but if each is made from two small triangles, then they cover the same amount of space. So they represent the same fraction of the whole. This is huge for developing understanding. Equal pieces don't have to be identical in appearance. They must be equal in measure, length, or area, depending on the context. You're doing exactly the kind of thinking strong teachers need.